Welcome to qnawire.
So for part A, they want us to find the velocity as a function of y. So we're going to use kinematics because this is the easiest way to solve for this. And we have the kinematic equation velocity final squared equals velocity initial squared plus 2g change in y. Change in y is simply y final minus y initial. And if we assume the y initial is going to be 0, we can simply say that delta y is simply equal to y, some height change in some height change. So if we say that this is going to be the velocity initial is also equal to velocity naught, we can say that the final velocity v is going to be equal to the square root of VO squared plus 2GY. And now, of course, this would be our velocity in terms of y. So you have a function for velocity in terms of y, and now they're saying find the velocity, the radius in terms of y, find a function for radius in terms of y using the equation of continuity. So the equation of continuity simply states that the cross-sectional area of the pipe times the velocity going through that section of the pipe equals the cross-sectional area of the second section times the velocity through that second section. So the cross-sectional area of a pipe is simply the area of a circle. So we're going to say that the first section is going to be pi r o squared times that initial velocity, and then we're going to say pi r squared times the velocity in whatever in the second section of the pipe, wherever that may be. So, and what we're trying to find is a function for r. So we're trying to isolate this variable right here. So we can plug in what we found in the first part for v. So we can say, first of all, we can cancel out these pi's for sure. And so we can say r squared. And then we're going to say the square root of, again, v0 squared plus 2gy. And once we have that, we can actually divide, because we want to isolate this variable right here. So we can say that r squared is equal to velocity initial, radius initial squared, times the square root of velocity initial squared plus 2gy. And we're just going to have to take the square root. So r is going to equal, this is going to be r sub r naught times the square root of the initial velocity, and then divided by velocity of the initial velocity squared plus 2gy all to the 1/4 power. So this would be, I guess, part A, the first part of A, and then this would be the answer for the second part of A. This would be the essentially our r of y, and then this would be our v of y. And then it's asking, given that the radius, how far along the stream will the radius of the stream be halved? So essentially find y such that the radius of the stream is halved. So if we were to get a new workspace here and say that the radius, the new radius is going to be the initial radius divided by 2. So that means that the radius of the stream has been halved. Where does this occur? How far down the stream does this occur? So we can say, so we can bring back this equation here, and we're going to say that r squared is again equal to the initial radius over 2 squared, and this is going to be equal to velocity initial squared, and then the square root of the initial velocity squared plus 2gy. And at this point, we see that we can cancel these out. So this is going to be r squared, this is going to be r squared, they're going to cancel out, and we're going to end up with 1 over 4 equals the initial velocity divided by the initial velocity squared plus 2gy once again. And at this point, it's a lot of just algebraic manipulation. So we are going to try to get this square root in this denominator. We're trying to simplify this. So we can say 1 over 16 equals the initial velocity squared. And then, my apologies, we're trying to get rid of the radical. So this will simply be initial velocity squared as well, plus 2gy. This is going to be equal to velocity initial squared plus 2gy, and this is going to be equal to 16 velocity initial squared here. And at this point, we solve for y. So this is going to be 15, and we have that y is going to be equal to 15 times the initial velocity squared divided by 2g. Now, the initial velocity squared, they're telling us that's going to be 1.2. So 1.2. So it's going to be 15, 1.2 meters per second, and then divided by 2 times 9.8 meters per second squared. And again, this is going to be squared. So if we were to plug this in, we see that it's going to be 1.1 meters. So this is how far along. So essentially, 1.1 meters down the stream, and the stream's radius is going to be halved from the initial radius of the stream. So this would be the answer for part B. And that's the end of the solution. Thank you for watching.